The title of this talk is Embodied Thinking Machines, or as I will call them, ETMs, as Translators, Problems and Possibilities. My name is David Vampola, and I teach at the State University of New York at Oswego. This presentation discusses some themes linking embodied thinking machines, or ETMs, to issues involving translation and interpretation, with a particular view on gestures. I feel that considering such a link can provide, 1, a conceptual locus for thinking about broad problems of semiotic representation. 2, more particularly for the translation community, it can provide yet another avenue for thinking about translation. Several caveats need to be noted at the onset. First, this presentation is not a rigorous examination of what thinking is. In particular, any relationship between ETMs and more nuanced issues in 4E, that is embodied, embedded, inactive, or extended cognition, are for the most part not treated here. Second, in recent years, scholars in the humanities and social sciences have been examining aspects of gestures far more than in the past, but this short presentation will not attempt to review and summarize these wide-ranging efforts. One aspect of thinking beings is to see them as communicating entities or agents. There is a long intellectual tradition that maintains that there is a connection between human thinking, or at least human planning and reasoning, and human social relations that are mediated by communication. Just one contemporary example is found in the work of Dan Sperber and Hugo Mercier. The Enigma of Reason, pictured here, is perhaps their best-known work, but they succinctly observed in an article published in Brain and Behavioral Sciences that, quote, "We view the evolution of reasoning as linked to that of human communication. Reasoning, we have argued, enables communicators to produce arguments to convince addressees who would not accept what they say on trust. It enables addressees to evaluate the soundness of these arguments and to accept valuable information that they would be suspicious of otherwise. Thus, thanks to reasoning, human communication is made more reliable and more potent." Translation is an important part of communication. Translators explore aspects of a text in its context, analyze texts, make decisions about what expressions to use in a translation, generate textual material, and communicate their results to an audience. But beyond these more conventional practices, there are ways that the usual notion of translation can be extended. This operation of enlargement can be expressed by English words designated with the prefix trans. This insight, developed most notably by the translation scholar Cobus Murray, involves an examination of translation processes identified with the terms transorganism, transorganic, transhumanism, transmission, transduction, transformation, transscience. These can denote linkages between potentially new practices of translators, which can be extended to areas not conventionally identified with the term translation. The introduction of ETMs allows for other dimensions of translation to be considered. In particular, the translation of gestures as language allows for this perspective. As mentioned earlier, gesture has been given increasing attention by scholars and scientists over the past 30 years. The reasons for this increased interest are multivarious. 1, with the growth of human-computer interaction as an activity in the information economy, increased interest is being paid to communicating with machines via gestures. 2, in the biological ethnological domain, scientists interested in animal communication have been examining gestures both from an intra- and interspecies perspective. 3, cognitive psychologists have been concerned with the implications of gestural communication for psycholinguistics. 4, as alluded to earlier, scholars of translation have been interested in the possibilities and problems associated with machine translation. The recent somewhat spectacular advances have largely centered on text. With the prospect of ETMs, the area of bodily expressions and their interpretation as a form of translation can be explored. There are several initial challenges that must be overcome. These, in principle, are within the extended range of present technology. One is the corporeal capability of expressivity. The actual mechanical bodies must be capable of conveying gestures. Here, not only must the facial expressions be capable of making gestures that can be expressed, but the movement of the ETM's body must also be flexible enough to physically make the gestures. Another challenge is found in the domain of pedagogy. Here we consider the education of ETMs through the machine learning of gestures. Only one aspect of what is associated with machine learning can be treated here, and that is the role of feedback. The purpose of feedback is that it allows appropriately designed software to learn according to a well-known psychological model, that of error-driven learning. In a macroscopic domain, this is what happens in a classroom. If a student makes a mistake or error, she is ideally given information to correct her mistake. The student is given the correction every time there is a deviation from the correct answer. In this view, the learning of gestures becomes one of association. In this model of learning, mental representations are primarily weighted connections between nodes that have stimuli inputted into them. But there is a problem with pedagogy. Here we are concerned with the context sensitivity of gestures. They are not necessarily universal. As the scholar of gestures, François Caradac, has noted, quote, "There are no universal gestures. Western good manners would have us look at the person with whom we are speaking, whereas in Asia and Africa, we do not look at a person whom we directly respect," unquote. In addition, Caradac notes that gestures can change over time. Hence, gestures can be differentiated by both geographical distance and time. Possible approaches to addressing polyvalent meanings in gestures is to create virtual environments that can, 1, represent multiple meanings in a hypertext hyperlink format. This is what software specialists at Google who are working on the Google Translate program are doing to provide contextual information to disambiguate translation. With respect to ETMs, a text transformation program can be used, which is in turn linked to an appropriate gestural expression. Second, on a more advanced level, simulated environments can be created that allow ETMs to learn the culture in which a term is embedded. The task of translation here is to change media from codex paper-based systems into virtual worlds in which machine learning algorithms can operate. In thinking about gestures, we might want to also consider the process of interpretation and meaning. There is a larger question for translation scholars beyond the possibly insurmountable problems surrounding the physical realization of gestures and teaching ETMs to recognize the contextual factors that give gestures meaning. Many scholars interested in language are also concerned with the processes of interpretation and the creation of meaning. How can aspects of interpretation be approached in the world of ETMs? An outline of an approach is given by N. Kathleen Hales in her article, "Can Computers Create Meanings? A Cyber-Biosemiotic Perspective." This article is found in the autumn 2019 issue of Critical Inquiry, whose cover is pictured here. Hales, in her usual trenchant transdisciplinary approach, tackles a number of themes in this paper. But for the purpose of this presentation, only several will be appropriated from her work. Hales recognizes the dynamic developmental course that humans have experienced, along with the role that machines have played in that evolution. She envisions a, quote, biotechno-evolution, a hybrid process in which information, interpretations, and meanings circulate through flexible, interactive human computational collectives, or, in my terminology, cognitive assemblages. This cognitive assemblage notion is a key idea in the thought of Hales. Another way she puts it, quote, "I conceptualize an assemblage as a flexible and constantly shifting network that includes human and technical actors, as well as energy flows and other material goods." A cognitive assemblage is a particular kind of network, characterized by the circulation of information, interpretations, and meanings by human and technical cognizers who drop in and out of the network in shifting configurations that enable interpretations and meanings to emerge, circulate, interact, and disseminate throughout the network, unquote. Given these definitions, ETMs can be considered technical actors that are present in the network assemblage that Hales describes. As such, they can be part of this web of interpretation and meaning making. For Hales, given the capabilities of these cognitive assemblages, it is an expression of anthropomorphism to consider only humans as capable of interpretive activity. The notion of cognitive assemblage thus can include ETMs within the community of meaning makers. The work of American polymath C.S. Peirce has been seminal for those interested in semiotics and theories of meaning. For Hales, the semiotic approach of Peirce can be used to understand the structure of interpretation within the framework of cognitive assemblages. What is Peirce's theory? And here I have to be extremely brief. We can think of Peirce's theory as being a theory of signs, and he is concerned with the definition of sign and its relationship to representation. A sign, or representatum, is something which stands to somebody for something in some respect or capacity. Now, allow me to break this down and clarify it, albeit briefly, here. I want to stress that Peirce's views on semiotics and the process of semiosis are quite complex, and I'm only treating one part of it here. Meaning is related to the interpretation of signs. For Peirce, signs consist of three interrelated parts. First of all, you have a sign or a signifier or sign vehicle. And here's some examples. You could have a written word, which we have in front of us, an utterance in speech, and we can see smoke, and this could be a sign for fire. Our world is filled with these signs. Second, we have an object which is signified. So, for example, the object to which the written or uttered word attaches. So if you think of, let's say, a pencil that you have in your hand right now, you have the word pencil, and it refers to the object pencil. Or in the case of fire, we can see that signified by the smoke. There's a relationship there. And again, going further with Peirce, he has a cognitive theory talking about the relationships between signs and objects. But finally, we have an interpretant. And this can be thought of as the understanding that we have of the sign-object relationship. So as you are looking at this slide, you see signs in the form of the actual physical inscriptions that are found on the slide. These refer to particular objects or concepts, but then there is you. Each one of you is an interpretant, bringing together the signifier and what is signified. Now let us turn to the application of Peirce's semiotics to cognitive assemblages. Peirce's theory developed before the advent of not only computational agents, but electronic computers themselves, attempted to explain interpretation by humans within human communities. Although Peirce's views were not well known in his lifetime, scholars in various disciplines, particularly those concerned with interpretation and meaning, have embraced and extended his philosophy. The implication here is that software, specifically computational models of neuronal activity, can establish such connections that are formed over time by repeated exposure to stimuli. Given the ability of machine learning algorithms embodied within ETMs that can make associations, ETMs can be considered within the community of interpreters. This, in turn, means that they can potentially interpret, translate gestures, and, as meaning makers generate them. We can ask the question, is Peirce's view simply a schematic structure that accounts for the relationship between the gestures by an ETM agent as signifiers, their referential meaning, and the interpretants, ETMs, in a translational situation? Another way of putting this is this simply a description of behavior? Now, consider the following two quotes by translation scholar and award-winning writer Jhumpa Lahiri. She writes, "For to translate is to look into a mirror and see someone other than oneself. Also, to translate is to alter one's linguistic coordinates, to grab onto what has slipped away, to cope with exile." Here, Lahiri is positing a subjective human experience for translation that may not be captured by textual and gestural expressions generated and interpreted by ETMs. This is a vast subject, but at the very least, thinking about the pedagogical dimension that involves training ETMs using machine learning methods, one must suppose that these networks of association do not really capture what Lahiri says is essential for translation. What might be the case is that there is a return to symbolic approaches to AI, in which the necessary and sufficient conditions for describing mental representations that are used in language, in this case gestures, are developed. So, by way of a conclusion, and I think that we need to take all of these caveats that I mentioned earlier into consideration and just treat them as constraints, as good AI modelers always do. We need to move ahead. Now, I say here putting aside ethical considerations. Ethical considerations are extremely important. In what respect, you might ask? Well, perhaps ETMs should be considered as persons, but I'm going to leave that important concern aside. But putting these ethical considerations aside, I believe that ETMs can serve as a potential platform for testing theories about translation, meaning, and the ways that gestural communication can construct our world. Thank you for listening.